All right, let's take a look at the Mod 5 Day 12 worksheet. And we're starting at the top with our angle relationships. Remember, we're not only going to solve for x, but we're going to give the angle relationship name as well. So looking at 1a, do you see that relationship there in between vertical lines? You got it. That one is alternate interior angles are equal, or alternate interior angle theorem. So now we just get to set those two equal to each other. So setting them equal, we're going to move the x's together to the same side by subtracting. And then we want to add the 4 to the other side. So we're going to get 2x equals 9. Divide by 2, and we get that x equals 4.5 degrees. Remember that our units here are degrees. So minusing the x, did that make sense to you? Adding the 4, did that make sense to you? And yes, we can sometimes get a decimal on these. They don't come out to nice whole numbers. Just be prepared. Okay, on the next set, there's a couple different ways you could go about this, but do you see how the 6x is an exterior angle and the 5x minus 1 is the exterior angle? There is an angle relationship that states alternate exterior angles are equal. And the reason is the 6x is also equal to this vertical angle, and this vertical angle now is a corresponding angle to the other one. So there is a theorem called alternate exterior angles are equal. All right, so that means we can just set these equal. Go ahead and try it. And it gave us an invalid answer because we cannot have a negative angle measure. I guess x could equal negative number. I don't know. I never try to make these come out to negative, so sorry about that. But since it's just the x value, not an angle measure, I guess it would work. Okay, next one. Do you know that relationship? You got it. Those are vertical angles are equal. So x plus 7 is equal to 4x minus 3. So if we minus the x's from both sides, and then plus the 3 to both sides, we're getting 10 is equal to 3x. So divide by 3. So you can leave it as 10/3 degrees, or you can divide 3 into there and get 3.333333 repeating degrees. So we have this as part of our answer, as well as the x equals. That negative answer is annoying me. I'm never going to do that to you on a quiz or a test, okay? All right, this next one, this little x over here means that by vertical angles, wouldn't there also be an equal x right there? So first we use the concept of vertical angle theorem just to move that x to the other side. And then we've got two same side supplementary angles inside of those parallel lines. So we're also thinking of same side interior angles are supplementary. All right, so that means we can go x plus 24 equals 180. Grabbing a calculator, 180 minus 24 is 156 degrees. So we've got our reasoning up here, our angle relationships, and the answer. Next one, do you know that relationship? You got it. It's exterior angle theorem. That states that the exterior angle is equal to the sum of the remote interiors. So let's minus the x's and minus the 1 and divide both sides by 7 is going to give us a decimal. 25 divided by 7. So again, you can leave it as 25/7, or you can round 3.57 degrees. So my answer is not only the degrees, but the angle name. Okay, this last one are two parallel lines inside of a right triangle. So that makes us like, whoa, have I ever seen anything like this before? But you just have to think a little bit about it. Check this out. Isn't 71 a linear pair to that other side? So couldn't I use linear pair to go not x. Let's give it another name like y. Since it's a linear pair, it adds up to 180. So grabbing my calculator, 180 minus 71, you got it, is equal to 109. So technically, I just found this angle over here is 109. And by parallel lines, we know that this right here is parallel to this. I know that corresponding angles are equal. So I technically know that this x down here would also be an x up here. So now I've got a fully completed right triangle, and I know that right triangles, or all triangles, add up to 180. So couldn't I say x plus 109 plus 90 equals 180? Because that little square at the bottom there, that means 90. So I'm going to get x plus 199 . And again, we gave you invalid numbers here on the worksheet. So to make this valid, we got to change the outside angle to the 71. Sorry, the inside angle. So we got to make the outside angle 109 and the inside angle 71. Now let's do it. X plus 71 plus 90 equals 180. And so 70 plus 90, that's 161. And 180 minus 161 is 19. So what went wrong on this worksheet is that obtuse angle, we gave the value of 71 instead of the 109. And so then that made it an invalid possibility. When we solved it, it's coming out to a negative number. Okay, so now that helped us solve for x. And what are all the things that we used besides having to fix the numbers? We had to use linear pair. We had to use corresponding angles. And we had to use triangle sum theorem. Okay, sorry about the error on that one. Some of you probably in doing that were like, what the heck is going on? Okay, in this next one, we're doing semester 1 solving quadratics. And so this is making you go back and think about what are the three methods. Here it specifically asks you to use the formula. Here it asks you to complete the square, even though there's a coefficient greater than 1, and it leaves the first one open. So usually that means it's factorable. So let's take a minute to see if any of you noticed this. 2x times x makes 2x squared. 5 times 1. If I do it like this, this makes 5x and 2x. That's not going to give me my middle term, so let's try it the other way. How about 1 and 5? Now that's going to make 1x and 10x, which is 11x. So let me show you this all the way out so you can see what I mean. 2x times x is 2x squared. 2x times 5. 1 times x. 5 times 1. And there's my original quadratic. Okay, so those are my factors. This is factorable. So notice that I set the factors equal to 0. but I'm being asked to solve, so keep going. 2x plus 1 equals 0. X plus 5 equals 0. I get one solution of negative 1/2 and a second solution of negative 5. So again, what do these solutions even mean in quadratics? Back to semester 1. It means I've got a parabola that's touching at negative 1/2 and negative 5. Those are my two solutions, my two real roots, the two places it touches the x-axis. So we used to write two real roots on stuff like this. There's no i's in my answer, and it was factorable. Okay, so if you didn't notice that that was factorable, you could have chosen a different method. Because the middle term is not even, I would have gone formula. You should have still come out to negative 1/2 and negative 5. Let me know in class if you want to see that full thing done as the quadratic formula. Okay, next one. We are not ready to start solving this with ABC until you move the 8 to the other side by adding 8 to both sides. So here, you need it to be equal to 0 before you can start getting ABC. So now I'm ready. A is 3, B is negative 4, C is 8, X equals negative B plus or minus square root B squared minus 4AC all over 2A. Take a minute to see if you can see where each of those comes from and that that's where you plugged it in. Pause it here and try to see how far you can remember how to simplify from here. Remember that the next step, I expect everybody to get to that, but it's how many steps further than that can you keep going? Okay, let's see how you did. Did you simplify the positive 4 on top and the 6 on the bottom? And then inside, did you get a 16? 4 times 3 is 12. 12 times 8 is a 96. How'd you do? So what is 16 minus 96? It's negative 80. Remember that whatever we get under that radical, we go off to the side and we say what times what makes 80. So remember there's a negative in there, so there's going to be an I in my answer. And then 80 is 8 times 10 or 4 times 20 or however you broke it down. But 8 can keep breaking down to 2 times 2 times 2. And 10 is 2 times 5. And there's this negative 1 there. So here's my smallest factors. A 2 comes out, a 2 comes out, an I comes out, and a 5 stays in. How'd you do on that? So we get x equals 4 plus or minus 4i root 5 over 6. And there's one final step of simplification that's needed where what can go into 4, 4, and 6? A 2. So my final answer for this one is 2 plus or minus 2i root 5 over 3. How did you do on that guy? Oops. I don't want that. I want the highlight. Woo, that one was bringing in all the old stuff. Okay, let's go check out the complete the square and see if that one's any better. So on this one, remember how Miss Sanchez likes to write the 0 on the left, so we have the space to make space. So we go 0 equals 5. So start by dividing a 5 out, divided by 5, and making space. So 5 comes out, x squared plus 6x, leave space, plus 70. Then we're saying to ourselves, let's go do the B work. What could I add to this to complete one square? And so off to the side we go B squared. B divided by 2 squared is 3 squared. So we're going to be adding 9 and subtracting 9 5 times. Why is it 5 times? Because we had divided a 5 out originally, and this 5 is distributing with the 9. So adding 9 5 times and subtracting 9 5 times. This is one of the big mamas. Okay, now what factors can we get from that? So the x plus 3 squared factors. And then at the back, I've got 70 minus 45 that I need to simplify here. 9 times 5 is 45. And then 70 minus 45 is 25. And so we're going to subtract 25 from both sides, bringing the constant over. And then divide by 5, giving me negative 5 is equal to x plus 3 squared. We want it in this format so that we can solve now by square roots. Square rooting both sides gives us I root 5 is equal to x plus 3. And last step of minusing 3 from both sides, and I'm going to flip it around, gives me negative 3 plus or minus I root 5 as my final answer. Woo! Another goodie. How far did you get on that one? On your own. So let's say you just watched the video and didn't do it on your own. I highly recommend that both Part B and Part C, you practice those in your notebook right now, not only making notes for yourself on 2 more difficult quadratics, but so that you can see how far you can do it on your own now. Because guess what? That's coming up on the test still, Mod 5, at the end of this month. All right, hope you're doing well. That was page 1.